Hello everyone, my name is Satyam, and in this video I'm going to guide you how to create a full stack application on Aztec. So I'm going to divide this into three parts. First we are going to write a voting contract, and then we are going to test this voting contract with our node script. And lastly, once we are sure that voting contracts works fine, we are going to integrate this voting contract with our front end to call all the methods like cast vote, getting the vote tally, as well as ending the voting with our UI. And this we are going to do with Obsidian wallet. uh, but this starter could also have integration with the AzGuard wallet. So if you want to take a look at it later, how to do the same thing with AzGuard wallet, you would be able to do it. Okay, so let's start. So let me just first of all guide you through the project structure. So our contracts, Aztec contracts will be in the circuit slash voting contract. Frontend is written with Next.js, so it uses Next.js and React, and all the Aztec dependencies are already there. So we have basic boilerplate code already set up. So let's start with the voting contract. So we are going to create a file nargo.toml. Nargo.toml is what you can say. So if you are from the Rust background, you might be aware of the file named cargo.toml. Similarly to that, there is a nargo.toml to manage hashtag contracts, dependencies, as well as the package, compiler version, and all all such things. So we are going to basically create this package. Okay, so I'm going to name this simply voting contract. Okay, type. So project type can be if it is just a simple Noir project with because you can use Noir outside of hashtag contracts as well. You can keep the type as just binary, and you can write circuits in Noir, and you can also create Noir libraries with the type lib. But in our case, we are going to create a contract, so I'm going to give a type contract. Let's just keep authors as well. This is optional. We don't really need to do it, but I'm going to still do it. Okay, and compiler version is also one field that you should definitely use. Compiler version is basically signifies the minimum compatible compiler version, because Noir is still in the development is still in progress, and your contract might use some features which is not available in previous compiler versions. So defining this is also very important. So I'm going to use compiler version 0.18.0. Okay, now is the time for the dependencies. So the main dependency that we are going to use is the Aztec, since we are creating Aztec contract. And there are other dependencies like if you are using nodes, then address nodes and other token contracts or other things. But we are going to keep things really simple here. So I'm just going to mention the dependencies as the Aztec dependency. So the way you define the Aztec dependency is you define the GitHub repositories. So let's say hashtag packages. So I'll just copy this. So you define get request to hashtag packages slash tag. Now what is tag? So tag is the specific tag of if you want a specific version of this, and this version really, like the contracts version depends on which sandbox or which libraries you are going to use. So we are going to use version 0.87.2 since this is the latest testnet supported version. So we are going to use this. Okay, tag equals to 0.87.2, and directory is essentially the path of the Aztec inside this repository. Since this is a mono repo, you can see there are like a lot of projects here. So Aztec in itself is inside the Noir projects, Aztec Noir, and there is a Aztec. So this is the path. Okay, so directory is okay. So this is all that we needed to do in order to basically get the Aztec dependencies. And once we do nargo build, Aztec nargo build or Aztec nargo compile, the compiler, it will Aztec nargo tool will just pull up these dependencies from the remote and will get it in your local. Okay, so the way contract structure is defined, its entry point is always src main.nr. Okay, so this is where we are going to write our contract. So let's start writing our contract. So we'll just do pub contract, and I'm going to use simple this name voting contract. Okay, and we are going to define this, we are going to add a macro Aztec. Now what this Aztec macro is, these macros are sort of like, things in Aztec which expands into the code, right? So once you add a Aztec, macro here, this will be considered a Aztec contract. So we need to import this, and the way we can import it is dependency Aztec macros Aztec. Any dependency that you define here will be available through dependency. So we have defined this dependency as stack. So we have defined this dependency as named as stack. So we are able to access this. Okay. Now let's basically try to see what are we going to do with within our voting contract. Like what are the essential components of voting? So first of all, okay, essential components of voting. Okay, I'm going to close this. So essential component of voting is, first of all, users should be able to cast vote. Cast vote. Uh, Cast vote to whom, right? When you are casting vote, let's say in your election, you are casting votes to the candidates. So similar to that, here as well, you are essentially casting a vote to a candidate. For the sake of simplicity, we can think of like candidates represented by like serial numbers, like candidate 1 2 3 4, things like that. But here is a bit of a thing, bit of an interesting thing, that you want to cast vote in a private manner. What do I mean by private manner is that when you are casting a vote, your address should not be revealed, as well as the candidate that you are casting vote to, that should not be revealed on chain. The reason, or you can think of it that, like, if this information is public, other candidates, when they win, they can hold a grudge against you. Like, you want to keep this information private, just like in real world. So cast vote, this should be private, i.e. not does do not reveal wallet address or candidate I voted for. Okay. So that is first function. The second thing is we should be able to get the vote for each candidate, like get vote count for candidate. And the last thing that I think is useful is like whoever is conducting this voting, they should have this authority to end the voting process, right? So the results can be announced. Voting cannot definitely go for forever, like 5 years, 10 years. It will have a specific period of time, 1 day, 2 days, 3 days, or just few hours, right? So end vote, admin authority should be able to end voting process. So these are the main three things. You can definitely expand this functionalities to as much as you like. Suppose that you only want to allow users to cast vote if they hold some tokens, right? Some particular ERC20 token or some NFTs, so that you want to only your community members to vote, not anybody who had the Aztec wallet address, right? So you can basically constrain this as well. You may want to do not start the voting process right now and may want to schedule the voting. So yeah, you can make this as complex as you want. But since here we are trying to focus right now on how to write a very basic contract, and how to integrate this contract with front end in order to create like end-to-end application, we are going to keep things really simple. Okay, so we have this thing now. Let's create this basic structure. When I say basic structure, I mean just like the skeleton functions. Okay, so what I'm going to do first, I'm going to do few imports from the Aztec. So dependency Aztec, okay, and macros, functions, macros. So I need few macros from this dependency hashtag in order to basically declare functions and other structures. Functions initializer. This is for our constructor. So as I write down the applications, I will explain to you what is the meaning of each of this macro is. Utility, okay, and storage, okay, and I think that's it. Okay, so dependency hashtag key macros, that is fine. And sometimes this is again also the thing, sometimes you will see this red squiggly line for a long time, and if it doesn't go away, you can just reload the window and it will go away. Okay, sometimes this VS Code, Nargo, hashtag extension have a bit of a delay. Okay, so next we are going to also import dependency hashtag. We can also definitely do it inside this previous block, but I don't want to make this too long. Hashtag address, map, public mutable and public immutable. Okay, and okay, so let's start with these right now, and as we'll need more, we will import more dependencies. So the basic structure of the Aztec contract is you have some sort of a storage, right? If you are coming from the Ethereum world, you might be familiar with every contract usually have this storage. Similarly to that, in Aztec contracts as well, you have some storage where you can define where you can define things to store that are particular to this particular contract. So struct, storage, and context. So context might be a bit confusing to some people, who are not aware of privacy focused chains. So I don't know, if you've gone to the hashtag docs or know basics about the hashtag, but just to recap, hashtag is privacy focused layer 2 chain, right? So essentially, you can execute things in private without where the data doesn't leave your browser, and you can essentially prove that certain conditions hold. So there is a context of private context versus public context. Private context, everything happens on your machine, data never leaves your machine, and then there is a client side proving that generates proof, and basis essentially with those proofs you are able to prove that things happened on your machine was according to the rules. Okay, so that's why the context is posed. So there are two contexts. If you understand, if I paint with broad strokes here, there are two contexts: public context and private context. Okay, so we are going to define admin in our storage. Admin is the address who is deploying this contract, who have this authority to end the voting, and I'm going to keep it as public mutable. Admin will be some hashtag address. Okay, and tally is like vote tally is essentially each candidate have how many votes, so it's sort of a JavaScript object, right? So something like this: candidate 1 vote 10, candidate 2 vote 20, and so on, right? So this is a tally, and to define this in the hashtag contract, we can use map, and map is for field is for candidate ID, public mutable, field context. Okay. Voting ended is the voting is still going on, so it's just a boolean. So public mutable boolean context. Okay, and we are not going to define any other thing. I think that is just fine. Yeah, so sometimes you see this red squiggly is there for bit amount of time, then it goes away. Okay, so we have defined our storage. We know what are all the things that we need in order to store in our contract. Now we are going to define a constructor. Okay. Constructor in Aztec contracts doesn't necessarily have to be named as the name constructor. You can mark any method as constructor as long as it does have this initializer macro. But obviously, just to make the things obvious, I'm going to create the method name constructor. But this is again this should be this can be constructor one, constructor two, other thing like foo, bar, anything, right? So the method name doesn't necessarily matter here as long as this have this initializer macro. Initializer. Okay, so in constructor we are only asking for the admin. So admin would be of type hashtag address. Okay, storage dot admin dot write admin. Okay, and we are going to check, we are going to basically initialize voting ended as well. So when you are just deploying the contract, the voting ended is false. Okay, that's it. That's what we need. Okay, so let's just try to, when you're writing a contract, extra contract for the first time, I would suggest do not try to tackle the whole thing at once. Like just compile iteratively, build iteratively, so that you'll gain confidence. Okay, so cd circuits the voting contract. Okay, so what is the command to compile this is compile the contract is just go to your contract folder and run hashtag nargo compile. So Aztec Nargo compile is successful. If it is not successful, you will get some error. For example, like this. If I just now run it, I'll get some error, right? So, okay, so we see a couple of warnings, but we are not too much bothered about it since we are going to use these remaining, macros and things later. Okay, so our contract compiles successfully, and once the compilation succeeds, you will see the compilation output in the target folder, and the target folder will have this, compile this generated JSON file. This is like, what do you say? The not essentially the artifact, but the output byte code and all the things. It does have all the things. Yeah. Okay, so now what we are going to do, so we have our constructor, we have our storage. The next thing is to write down those methods. So we are going to first of all create a method of get vote, so like just getting all the votes. So we are going to mark this function as utility function since it doesn't change anything. Okay, unconstrained function get vote. Okay, and we are going to get a vote for candidate, so we need candidate in the parameter, candidate id, essentially candidate field. Okay, so the way we read things from storage is just storage and variable name tally dot add candidate dot read. Okay, what is the, okay, this Noir language support formatter is running, and I believe it will be successful, so I don't worry about it. Okay, let's create this method of ending the vote. So I'm going to mark this as public and vote. So first of all, I'm going to check this. I'm going to have one condition that whoever is calling this method and vote is the admin, right? So only admin should be able to call this method. So I first get the caller, let caller is equals to context dot msg underscore center. Every method, inside every method, this context thing is available, and context have various information like block numbers and things like that. So I would suggest, like, if you want, just go to the Aztec docs dot Aztec network and just search here for context, and you will be able to see all the things that is available inside the context, right? So this is the information of the private context. Then you can have the information of the public context as well. So for example, this context or block numbers and all those information is available in context and inside every method. Similarly, like you see, the message sender thing is available. Whoever is sending the message sender is the account that sends the messages to the current context in the first call of the kernel circuit. Okay, so let caller is equals to context dot message sender, and we check this condition. Let read this admin is equals to storage dot admin dot read, and we make this assertion. So assertion is sort of this constraint that we are putting inside of our function, or like you to use the ZK terminology, circuit, right? Essentially, every method or every function in your contract is a circuit, zero knowledge circuit. So we are putting a constraint in this circuit that this value of admin should be equal to the caller, or the value of caller is equal to the admins. Essentially, whoever is calling this method is the admin address. Okay, so we are going to put admin dot equal caller, and if that is not the case, you can say, let's say, only admin can and puts. That's it. I think there is one more here. Okay, so now for the final method is the most important part of the contract, and that is to cast the vote. And we are going to keep this method private, as I mentioned earlier, that we don't want to reveal which candidate we voted for, as well as our wallet address. So this execution should happen only on our browser, and on chain there should not be any information revealing our wallet address as well as the candidate information. Cast vote candidate field. Okay, now here the things gets a bit interesting. So the way this private execution essentially works, so let me just basically explain to you how this private execution will work. How cast vote private execution works. And first of all, let me just give you a bit of a disclaimer. Like, this is not bit easy to understand. Okay, so this does have a bit of a learning curve, right? So for example, you need to know that the concept of private execution or private transaction in Aztec works on the UTXO model. Like, Bitcoin follows UTXO models where you have the nodes. So you don't essentially have the store or state, at the contract level. No, you have nodes. Those nodes stays either in the form of log, encrypted logs, or just on your machine. And what on-chain have this node hash tree. So node hash tree is basically every node will can have a hash, and that hash will be in part of that tree. So you can say that that node was created. And then you have the nullifier tree, which basically says that this node is spent or not. So I'm just painting with very broad picture here, but I would definitely recommend you to and go through this concept of nodes, right? So this is essentially the nodes or UTXO model, right? That explains the difference between private and public state. The private state uses UTXO tree, UTXO also known as nodes, and you have this public data tree, and in the UTXO model you don't have this node, you have this node hashes. So that's where you can get a bit of a picture of how this private state works. Okay, I'm going to put it here just for reference. So what we have here is whoever is casting the vote, right? First of all, I'll get the nullifier, I'll get says the nullifier public. The reason also is that only one person should be only able to cast one vote. So right, if you are again calling this method again and again cast vote, it should not work, right? So you should have only one vote and you are able to call it one time. That's all. Okay, so uh, how do I proceed with that is, first we get the whoever is sending this, whoever is calling this method, his nullifier public key, nullifier key, mm, nullifier key is hash. So okay, let me just write it down. MSG sender, message sender, essentially whoever is calling this hash. Okay, and I will call this with get public keys. And as we have seen above, we can get the sender with context.message sender. Okay, dot nullify public key master dot hash. Okay, this get public keys we haven't imported, so we need to import it. Keys getters get public keys. Okay, so we have got this master keys hash, and then we need to get this secret. Let's secret. So the concept of keys is very interesting in Aztec, right? So every application, essentially, every contract will have their own nullifier secret keys of apps, and the reason is if like your one key is compromised, let's say your master public key is compromised, right? It doesn't affect all of your application. So that is essentially the reason that you have those in siloed keys. And again, I can't stress enough that the best way, like I'm probably like probably explaining it in a very incomplete way, so I would suggest like just go through these docs. I'm painting with very broad pictures, so because we can't cover everything here in detail. Okay, so context dot request nullifier secret key app, and we are going to do message sender nullifier key, nullifier public key master hash. That's what we call it, nullifier public key master, if I'm correct. So we have these 3 or 4 types of keys, like nullifier keys, address keys, incoming views keys, and all those things. So the one that you are using a master nullifier public key. Okay, so we have got the secret. Now we are going to create a nullifier, and to use the nullifier, we are going to create the nullifier by hashing. So standard hash, so we have this pedestrian hash available from standard library. And what in the pedestrian hash, we are going to provide 2 things. First of all, the message sender, context message sender to field. Okay, because the pedestrian hash method only takes array of fields. So secret. So we've got this nullifier. We are going to push this nullifier in our context. Nullifier. Okay, and then we are going to then what are we going to do? First of all, let me just reload this to see if there is really any error or this VS Code, VS Code plugin is messing things up. Okay, I think we are good. Now there is one more thing, right? We haven't actually added any vote to the candidates here, and you can see this voting thing or vote thing is public, and we are right now in the private context, right? So the way essentially things works in Aztec, you can call or you can basically queue the public call from your private call. So private execution happens first, and then the public execution happens, right? And you can't directly change public states from the private execution. You can only do that in public execution. So we have to create some method that adds the tally, and then we will call that method from our public execution. So I'm going to create one more method. Okay, so just give me a sec. Okay, so the way I'm going to create is public, and I'm going to also mark this as internal. So nobody outside of this contract should be able to call this. That's why it is marked with the internal. Okay, fn add to tally public. Okay, candidate field. Okay, and we are going to add one more assertion here. Essentially, you should be only able to cast vote if the voting is not ended. Okay, so we are going to do assert storage dot vote ended dot read is equals to false, otherwise voting already ended. Okay, let new tally. First we read the current vote for a candidate. So storage dot tally dot add candidate dot read plus one. Okay, and then we do storage dot tally dot add candidate dot write new tally. Okay, so we have this new tally. We have this method add to tally public. Now what we are going to do is we are going to call this method add to tally public from our private context cast vote. Okay, so the way we call it is, so we this method is also of this contract only. So we are going to do reference the same contract, voting contract at we get this context address like context dot this underscore address. This underscore address references this contract's address. And now this might be a bit confusing to people who say like, okay, this contract is not yet deployed, right? And then how can there be an address? So that's not really the thing. The contract address always can be pre-computed, with the contract's parameters and deployers and this information. And only that particular address we can be sure will be there when the contract is deployed. So you have this pre-compute thing. Okay, then add to tally public candidate, and we are going to use this enqueue thing. So you are not essentially calling this method, you are essentially queuing this method, that this execution is done, now I am queuing this. Okay, so it's not necessarily that this will happen immediately. And mute context. Okay, I think we are done now. Let me just check my notes if I have missed anything. So we have this storage and things like this. Okay, I think we're good. Let's just compile this. Hashtag now go compile. Okay, there is some error. So you can see this cannot find get public keys in scope and cannot find trades thing in scope. So we need to add those things. Get public keys cannot find get public keys in scope. This is interesting because we have already added get public keys, storage, dependency, hashtag. Okay, I got it. What is the error? So this thing is not inside macros. So we can just do use dependency hashtag. Okay, and keys. Okay. Now also there are a few trades. This to field trade is not there. So we need to also import this thing. So use dependency hashtag protocol types trades and to field. Okay, let's compile this again. Clear, compile. Okay, there is one more error. What is this error? Okay, this is definitely not will be comma. Get public keys. Let's clear this again. And could not resolve getters. This should be getters. Okay. Now there is last error. The states hash is not there. So we'll add hash trade as well here. Just clear this and hashtag now go compile. Okay, so the contract compilation works fine. We can see that there is a target artifact. We can again try removing this and just to make sure. And yeah, so we get our compilation result. Now the next question is what to do next, right? So let me just come down here and mark this thing as done. Okay, so now our voting contract part is done. Now how we can test this voting contract? The way you can do it is you can either write a test cases in Noir, but the way I like to do it initially, is just trying these things out from my scripts. Okay, so we can create an script and we can see if all of these methods are working or not. Okay, we are going to close this. For that, we will first need to generate the TypeScript artifact for this contract. Okay, so I'm going to remove all of these artifacts method from here. There are, I think, some old artifacts, and we are going to run a new command. Pull it here. I'm just making sure that last terminal is not cutting from the recording. Okay, I think fine. So we are going to do is Aztec code gen and just the path where I want to generate this artifact. So we are going to generate the artifact in src artifacts. Okay. So our artifact is generated. By the way, this command will be in the README. So don't worry, I'm going to put all the commands in the README. Okay. So we have generated this artifact. Now uh, we are going to try all of these methods from our script, and in the last part we are going to integrate this contract with the front end. The reason I am I'm in favor of trying these things with the script is basically we try to tackle one thing at a time, right? For many people, both the Noir and the front end might be new, so right. So if you basically try to tackle all the things at once, things might get overwhelmed. So I would suggest like just keep things as simple as you want, as simple as you can, and then gradually move towards the front end integration. So what we have here is inside our script, I have created this basic CLI. So with this basic CLI, we can try all of these methods one by one. So we have this voting contract deploy, cast vote, get vote, end vote. And we can just call this CLI with one run CLI, and you will have, okay, not inside from voting contract. Okay, let me just close this. Go to the root of the project, and we can just do like one run CLI. So we have these methods, and right now it is obviously trying to connect to my Aztec Sandbox, which is not running. That's why we get this error. So let's run our Aztec Sandbox here. Aztec start -- sandbox. Okay, one more important thing that I want you to tell you is your sandbox version, your contract version, your front-end dependencies version should all be in sync. Otherwise you might get error, right? So you make sure the contract with the dependencies that you are creating here, version 80.87.2, it should be the same version as your Aztec Sandbox version. Okay, if you are trying to do things with Aztec Sandbox, many people want to do directly things with the Aztec testnet, but like I don't recommend it. First of all, Aztec testnet right now, things would be a bit slow, as you know, right? Because the testnet is completely decentralized from scratch, and many people are doing transactions on the testnet. And yeah, sometimes you might run into issues that are due to not your code, but due to the testnet. So that might make things a bit complicated for you. And besides, the sandbox is always up to date and it's very fast. It tries to it basically allows you to do things fast iteratively. So I would suggest go with the Aztec Sandbox. Okay, so we are going to check the version of Aztec Sandbox, Aztec -- version, and you can see this version is 0.87.2. If you want to use the new version, you can just do Aztec -up and define a new version. Okay, so but we are going to use 87.2. We have started our sandbox. Our sandbox is running fine. We see this message, Aztec server listening on port 8080. So that is fine. Now we are going to again run this one run CLI. Okay, so we get all the options. Okay, now we are going to basically start with writing the script. Okay, so let's start with writing the script. First of all, let me just explain the structure, the CLI script structure. So you have the CLI, and then you have these utils. What these utils does is do the basic, boilerplate thing, like connecting to your sandbox. So you just connect with the localhost 8080, create a Pixie client, setting up the nodes. If you need the wallets, it's just setting up the wallets. Like here, I am just creating 3 wallets here, right? And these methods probably we are not going to use mint tokens to wallet, but these are just the basic utility function that we are going to use. Okay, so let's start with first deploying our contract. So here, okay, so here in the CLI, maybe here too we don't have a, okay, so voting contract handlers. Okay, so we are going to deploy this function. So export const deploy voting contract, okay, is equals to async, and in all the methods we are going to take the pixie as the argument because I don't want to create a new pixie from scratch all over again. Okay, so we got this basic method. Let's import our voting contract artifact. Import from artifact slash voting contract. So voting contract. Okay, what else that we need? We need some wallets, but I guess in terms of the wallet we can get it here. So const wallets is equals to await, what is this method name here in our utils? Setup wallets. Okay, so we are going to call setup wallets, and we are going to call the pixie. So this setup wallets will give us, like, a couple of wallets, and now we are going to deploy our, we are going to get const voting contract is equals to await voting contract. Yeah, the reason you see this voting contract is essentially the artifact adds word contract. Okay, so if we want, we can just change the name here again and do the thing from again from start. But yeah, I mean, let's do that because I don't want to sound like voting contract. Okay, so cd circuits, sorry, cd hashtag react start plus circuits as voting contract, and I'm going to keep this as voting, and hashtag hyphen narco compile. Okay, we have to change it here as well, voting. Okay, and hashtag code gen, that's it. And then we can remove this old artifact if we have this old artifact. Yeah, let's just remove this, move to trash. Okay, voting, and then we will have now voting contract. Okay, so voting contract dot deploy the wallet that we are deploying with. So let me, every wallets will have 4 addresses, 4 wallets. So I'm just going to use wallets dot owner, and then the parameters. You can also hover this and see what is all the parameters that you need. So we also need admin address. So I'm going to just pass the same owner dot get address. Okay, and then send dot deployed. That's it. That's what we need. And now we do logger dot success voting contract deployed on address dollar voting contract dot address dot toString. Okay, so that's it. Just the 3 lines that we needed in order to deploy our contract. Now what are we going to do here is also we can return this, return just voting contract. Okay, so what are we going to do is use this CLI method here. So you can see here we have, I have left the comments here, deploy voting handler and all those things. So by the way, if you are trying to do this, let me just create a new branch, feed slash start voting hyphen start, and I'm going to push this. So this will not have any code, and you can try things from start, and I will create one more branch once all of this is ready, so you will have the final result also. Okay, so await deploy voting contract and pixie. That's it. That's all we need to do. So I'm going to run CLI. And what would you like to do? Deploy voting contract. Okay, so test wallet configured, voting contracts also deployed. Just a minute, I think Let me just check if the recording is still in place. Okay, so voting contract is now deployed successfully. Now let's try to do cast vote. For the cast vote thing, first we deploy the voting contract again. Let's say const await deploy voting contract pixie. Okay, maybe not good idea. So here what we can do, in terms of casting the vote, we will need the candidate ID. Okay, and the candidate ID is something that we can get from the CLI. So I can have this get numeric input. Just a minute. Okay, so I'll just can use get numeric input here. Const candidate ID is equals to await get numeric input. Enter candidate ID you want to vote for. Okay, and we'll have this candidate ID, and we will create another handler. So like cast vote handler and pixie and candidate ID. Okay, so we don't have this cast vote handler right now, but we can create this cast vote handler. Async pixie. Okay, and similarly to the before, we can get the voting contract, or we can just directly call the voting contract method from top, deploy voting contract pixie, and we can also get wallets here. Voting contract await voting contract wallets, candidate ID also we will get number, and we can call the method of const transaction cast vote transaction is equals to await voting contract dot methods dot cast vote. Okay, what does this cast vote takes? Candidate, so we can just pass candidate ID dot send dot wait. Okay, and logger dot success vote casted successfully. Okay, let me just change this to template spring successfully to candidate ID, and we can also print transaction hash, something like this, cast vote transaction dot transaction hash dot toString. Okay, so this is our cast vote handler. Cannot find name cast vote handler. Okay, so let's try to run things again. Run CLI cast vote. Let's say vote ID 1. So vote casted successfully to candidate 1. Okay, now what are we going to do? Now we can get vote and we can end vote. Okay, so export const, I guess the method of get vote would be very similar to the method of end vote. So get vote handler, so we can cast you vote to this candidate first, to which whoever you want to get the votes. Or I'm just thinking, what is the other thing that we can do? Like, what if somehow we can deploy the voting contract only once and then cast the votes again and again and again? That way, I think it would also work, right? So let me just see. I think it might work. voting contracts and wallets. Okay, so we can do like options, voting contract, wallets. Okay, wait, let me just do something like options. Okay, and with the options, or I guess just to keep things really simple, let's just do let voting contract equals to null, let wallets is equals to empty array, or just null. And here we can do voting contract is equals to okay, that's it. What else? If not voting contract and wallets. Okay, I'm just trying to see if this will work. Okay, voting contract null. And what is this? What does this set of wallets returns? Test wallets. Okay, so voting contracts const maybe contract, voting contract, voting contract. Okay, okay, const voting contract, voting contract. That is fine. If not voting contract, it's possibly null result. Voting contract is equals to result dot voting contract. Wallets is equals to result dot wallets. And that way I can be sure that this voting contract will be there. And just logger dot info deploying new contract. This is fine, I guess. Get vote handler also, I'm going to use the same thing. Cast vote candidate id, and we can just get vote. And when this is just a simple method, we can just do simulate. Okay, so vote count. Okay, so vote fetched successfully for candidate, vote count for candidate. Okay, and here we just do vote count. That's pretty much it. Let's integrate this get vote handler. Candidate id, get candidate id, you want to fetch vote for. Okay, fetch vote handler. I don't know, get vote handler. What is the name of this method? Get vote handler. Okay, so let's try to run this again. So we first deploy the contract. Okay, voting contract is deployed successfully. What I am also wondering of is why this exited. It deployed successfully. I guess there's some error here. this should not be breaking. So we just, keep running this. So deploy voting contract. Okay, so voting contract deployed successfully. Let's cast vote 1. Okay, vote contract successfully casted to 1. Again, okay, so this is what we talked about. So if you have already casted vote, we will not be able to cast vote with the same wallet. So if we are casting vote again, we'll have to cast with a different wallet, right? So this also we might need to fix. Let's do one thing. Here we'll say wallet number, okay, and cast deploy dot voting contract wallets if wallet number is equals to 1. Let sender let wallet equals to wallets dot owner. Okay, wallet equals to wallets dot user 1. If wallet number is 2, user 2, and if wallet number is 3, then we cast with user 3. Okay, and we can call this method with something like here with wallet, okay, and the wallet will always be there. So I'm just going to mark this as enforce this thing. So that's it. So if the wallet number is there, then we can basically, cast this vote with different wallets. In order to do that, uh, wallet number, enter wallet number, and just wallet number. Okay, let's try to do this thing like this. Run CLI, cast vote. So I guess we first need to deploy this. Okay, voting contract deployed, cast vote. So we have a casted vote with wallet number 1. Again cast vote candidate 1 with wallet number 2. You can see the vote again got casted, and then we are again going to cast with candidate 2 with wallet number 3. That's it. Now we are going to call get vote. For candidate 1 there should be 2 votes. So you can see that for the candidate 1 there are 2 votes, and if we again do get vote for candidate 2 there should be 1 vote. So you can see. So this is very helpful, these sort of scripts, when you are just trying out your contract, right? Yeah. So let's try to finish our third method as well. Export const get end vote handler is equal to async pixie candidate id, not no candidate id. Here we don't need candidate id. Okay, here also let's take the wallet number, because we want to also try to end vote with different wallets other than admin wallet. So since we already have this functionality, okay, then we can do is const transaction and vote transaction is equal to await voting contract dot methods dot end vote. Let me just do with wallet. Yeah, wallet dot methods dot end vote. dot send dot wait. Okay, logger dot says ended vote with wallet dot get address dot to string. Okay, uh transaction hash is also we can print end vote transaction hash dot transaction hash dot to string. Okay, so now we can integrate the end voting handler. I get the wallet number here and await get end vote handler pixie wallet number. Okay, now let's run this. Run CLI. Let's deploy the contract. Cast few votes. Wallet number 1. Again cast vote. Candidate ID 1. Wallet number 2. Let's again cast the vote. Candidate ID is again 1. Wallet number, let's say 9. In this case, the wallet will be the original admin wallet. Okay. We can again cast the vote to candidate with wallet number 3. So that will have, okay, I think we have already casted with wallet number 3 will also be a owner. So that's why we get this existing nullifier, since only one wallet can only cast one vote. So I'll tell you what is happening. So we entered wallet number 3 and there shouldn't be any condition with this wallet number 3. Oh, there is a condition with wallet number 3. Wallets, that then it shouldn't have one. Enter wallet number 1. Enter wallet number 2. Maybe the condition is incorrect somewhere. Wallets.user1, user2. Okay, let me just see. Maybe this method setup wallets have something. Okay, I see. So this is the fallback. If there is a not enough wallets, it will just use wallet 0. That's why it is failing. Okay, so now we have to run it again. Just cast vote and we can get the vote. Now we can end the vote and we end the vote with wallet 2. Then it should fail, right? So it failed. Deploy vote and voting contract deployed. Now we end the vote with, let's say, 10. Then the owner wallet will only be used and the voting will end. So ended vote with wallet. So that's how we basically can, test all the functionality. Let me create a new branch, voting /voting final voting contract and CLI script changes. So we have just to basically recap, we have this voting contract. We were able to test this voting contract with our CLI, and next we are going to essentially do is next we are going to integrate this with our front end. Okay, so now we are done with these 2 steps where we have successfully written the voting contract as well as tested this voting contract with our node script. Okay, now what we are going to do is create a front end, and we are going to call these methods cast vote, deploy voting contracts with a front end using Obsidian wallet. Okay, so let me close these, close others, and we are going to start this front end with bun run dev. By the way, instead of bun, you can use npm and yarn as well. I just prefer one. So localhost 3000, there should be our front end. So as you can see, there are a couple of errors here, and the reason these errors are here is because we have changed our contract name, right? So previously this contract name was Easy Private Voting Contract. Now this contract name is just voting. So you'll have to fix these things here. So we can just search voting and all the places where we have this voting contract. So we can replace easy private voting with voting contract at all places. Okay, that's it. And remove this. So we have replaced this. There are other files as well. Contract deploy already registered. There also we have to replace this with, first of all, okay, so I guess we are good. Register contract as guard as well. Voting contract artifact. There must be one reference as well. Okay, so let me break down this structure, front end structure to you before delving into what we are doing here. So this front end application is a Next.js application, and this uses app-based routing. So in Next.js also you have to do two things like page-based router and app-based router. So this is using app-based routing. The entry point for this application is layout.tsx. So in layout.tsx you basically define your project's metadata, that is for SEO, the fonts and things like that. And I am also using this to add header as well as a global context provider. In terms of global context providers, this is just setting up the various wallets names and things, and header is for connect wallet and setting up the wallet connection, all those. So this is just a basic pretty stuff like connect wallet button and things like that. And we are going to run this. Let's see if there is still any errors. So I guess live utils, we can just search easy private voting. Okay, easy private voting. So this is also an error. Voting contract artifact voting contract. This util file is also using this. Okay, so this is started, and you can see this is the home page of the application. Very simple, nothing like that. And as you can see, my wallet is already connected, but let me just disconnect this and click here on connect. Both the wallets in the Aztec ecosystem, AzGuard and Obsidian, are supported in this template. So you can either use AzGuard or Obsidian. Let's try things first with the Obsidian. So we click on Obsidian here. Okay, we can do this, but since I'm going to use the sandbox, so let me just switch on to sandbox. So this will take a bit of a time. Okay, that is fine. It is going to take a bit of time, definitely. So in the meantime, we can use AzGuard extension. So AzGuard is the Chrome app extension wallet, and Obsidian is the web UI based wallet. So you have both the options in the Aztec ecosystem, and both wallets are amazing. So there is no preference of like this versus that. So both wallets are good. Okay, so we connect our wallet, AzGuard wallet, sandbox, and our wallet is connected. So you can see B0F8 is the wallet address, and here as well B0F8 is our wallet address. Okay, now we are trying to deploy this easy private voting contract, and we can add the admin address. I'm going to use the same address as the admin address and deploy voting contract. Okay, this thing also will be a bit interesting to you. Pay fee with FPC. So every contract interaction requires some fee tokens. Just like in Ethereum, you pay fee with ETH. In Solana, you pay fee with Sol tokens. Here as well in AzGuard, there is fee token. And currently, there is no native token specific to AzGuard. So there are these fee-paying contracts who can pay fee, basically on behalf of you, right? So both the wallets have these, so you don't have to care much about the fee when you are just testing things out. So we have clicked on execute, and it will try to execute. And let's also just open our sandbox log so I can see if there is some things going on the sandbox. Processed one successful transaction. Okay, so contract deployed successfully. This is the contract address, and I believe you will see some transaction here, though I don't find it here, but usually also you also see logs here. Okay, so because this is the ultimate sandbox and AzGuard wallet is connected. Okay, so yeah, deployment is successful. We can cast the vote now. You might ask which candidate we are casting vote. So that thing is hard coded right now. So we can take a look at it like candidate one or two, which candidate is we are casting vote for. Okay, so the cast vote count for option one. This is like vote casted successfully, and we can check votes, and you can see current vote count for option one is one. Okay. Similarly to that, I guess we can have other options, other voting as well. So these methods, by the way, for the sake of this, guide, I've kept things really simple in just one simple file, not like make the whole front end too complex, so that people who are just starting out their journey, they have a place to see all of this, implementation at one place. Okay, and at a first glance, it might seem like a really big file, but the way I see it is till here only, because after these are just like UI components and just simple HTML to show things nicely on the UI. Okay, so you can see here is handle unified cast vote, handle cast vote. You can see that there is a cast vote thing here. Let's try to improve this. Okay, so instead of like casting vote just for option one, we should be able to cast vote for any candidate and then check vote for any candidate. Okay, so that's what we can do. Okay, so what we can do is okay, const candidate id, set candidate id is equals to use state. Let's say by default candidate id is one. Okay, and in this process we are also going to just take a look at these functions briefly. So this get voting contract is just for getting the contract instance, handle admin address change, register contract, deploy contract. It's the same thing that we were doing from the CLI script, but just using different wallet specific interface. So for example, if you want to deploy with Obsidian, you have this Obsidian contract interface. First to get contract instance, and then easy private voting dot deploy with options and deploy things. Similarly to that, if you have if you want to deploy with AzGuard, there is this method of handle AzGuard deploy, and AzGuard deploy you have different methods of deploying, and the way you are deploying this method is get contract deploy already registered, not this one. So you create the execute params. Okay, so you have this operations, and this method gets used to get the entire operations and things that you need to deploy the contract, right? So there is a register contract and instance deploy contract, all of this method. So yeah, check votes is fine. We can here just get the number candidate. Okay, let me just see number. Okay, candidate ID. Okay, so this will get a candidate ID. Candidate ID. Handle cast vote from AzGuard, and args would be candidate ID. This is cast vote from AzGuard. And vote from AzGuard. That is fine. Unified and vote. This is voting ended. You'll see cast vote here. Okay, so in terms of the cast vote, we'll just do input type equals to number, placeholder equals to enter candidate ID, on change value equals to candidate ID, on change equals to set candidate ID plus e dot target dot value. Okay, and we can just make this px4 6 py2. Okay, w full. Maybe this will give us a bit of good look. Okay, so we deploy the voting contract again, or we can like in terms of the input, we can directly use similar input as admin address. And realize we had this input, so admin address. So we have this input, actually input component. Input okay, input address. Let me just copy this and we can make the UI a bit more better. Checking votes, cast vote. Okay, and I'm going to paste it here. Candidate ID, candidate ID. This will also change to candidate ID. ID, type text value, candidate ID. On change, we are going to copy this. Enter candidate ID. Okay, and I'm going to just keep the class as font mono and border. Border. Okay, and this is, I think, fine. Just remove this. Let's see. Connect our wallet. AzGuard. Yeah, admin address. Same. Confirm. Right now, whenever you are doing things, we are not storing anything in local storage, so everything gets reset, right? But if you just indicate local storage, once the contract have deployed on Sandbox, you can again reuse the same contract again and again, right? So you'll not need that. Okay, so cast vote option 1, we are setting candidate ID, but let me just confirm where all places we are using. Okay, I think that is fine. So let's vote for candidate 2. Okay, so you can see the vote casted successfully. Then we can check votes. Current vote count for option 1 is 0. Maybe we are passing value 1, get voting contract. Let me just see which function that we are calling in terms when fetching the is casting vote, check votes. Okay, and the unified check votes, handle check votes from AzGuard, get vote. No, this will not be 1, this will be candidate ID. Okay, so check votes. Now you can see check vote, current vote count. But still, we are not showing. Checking is fine. Vote casted successfully is checking votes. Okay, let me just click again. Current vote count for option 1. So this log is correct. Incorrect. Current vote count. This one. Check vote results. Current vote counts for candidate. Candidate ID. Okay. And now we get correct. Current vote count for candidate 2 is 1. If we disconnect this, we are able to see. We can also try to do this with our Obsidian wallet. Okay, so our Obsidian wallet account is created now. Let's click on Obsidian, connect wallet. So our Obsidian wallet is connected, but I guess this state is something that we are seeing bit of incorrect. But still, I'm not going to refresh and just see if this works. Okay, so this is like now we are calling cast vote with different wallet address. Okay, sign transaction, send transaction. Vote casted successfully. That's amazing. Okay, vote casting happened successfully. Now let me just see if there are error. This error might be related to the Obsidian. Let me just refresh and deploy a contract with Obsidian all over again. Okay, sign and prove. Okay, so contract deployed successfully. Now we are going to cast a vote to candidate 3. Send transaction. And the reason it is happening very quickly is because we are doing things on the sandbox. If it would have been on the test net, things might would have been a bit slow. Okay, so cast voting happening. Cast vote transaction is there. So far we don't see any error. Let me just see if this is a UI bug or not. Casting vote. So we are showing casting vote, and is casting vote should be set to false. Handle cast vote, get voting contract. Okay. Voting contract dot method. I believe is casting vote, handle cast vote from AzGuard is fine. This one definitely not needs to be there, I guess. Okay, handle cast vote. We can definitely remove this. Chat votes. Let's refresh this. Try connecting our wallet again. This check votes is somehow failing. Is checking votes is cast vote. So this is handle cast vote. Let me just comment this. Sign transaction. Sign transaction. Contract deployed successfully. Cast vote. And transaction. Okay, so the vote casted successfully. Now we see check votes. So I believe in case of Obsidian, this check vote method is failing. That is why we were seeing this, infinite loader here. So we can see why this might be failing. Handle check votes. We can try to debug it. Whether this was working fine in case of AzGuard. It's okay. Handle check votes. Get voting contract. What is this? Not account. Easy private voting. Dot add address account. This is fine. Get voting contract. Handle cast vote also uses the get voting contract, so I don't think that is the problem. We are using method get vote. This is also fine. Dot simulate. Yeah, somehow this method is not working with the Obsidian, but we can it might be issue to be honest with Obsidian as well. I'm not sure, but yeah. So this is essentially what this complete flow is. The last thing that I'm going to show it to you is how to basically deploy a contract on the testnet. Okay, so this is what I'm going to do. Let's go to this .env and you just change it to testnet. Okay, and we reload this page. Okay, and in your AzGuard wallet, just select your network to testnet. Okay, we are going to again reload this until at least we don't see the testnet. So let me just restart this. Okay, I closed the sandbox, but that is fine since we are now going to deploy on the testnet. We don't need it. Okay, so now we are on the testnet. The only change that we have done is change the environment variable. Okay, that's what we have done. And I guess we can try to see if it works, deploys on the, if the transaction deploys on the test. Wait, did we selected the Obsidian? I guess we wanted to select AzGuard. Okay, approve. And this information you see is of the testnet. So the latest block on testnet is 17355. You can check it on Stack Explorer. So you can see the latest block is 17355. It's just 2 minutes ago. So we are fetching this information just to show how the testnet is behaving, like things like that. Okay, so let's see if there was any. Okay, I guess I rejected something. This shouldn't be the case. I rejected some pop-ups or something. Deploy voting contract, confirm. And guys, on testnet, this might take a bit of a time, right? Because you are uploading your entire content. Okay, deploy result fails. Okay, let's see if we are able to register the class first on testnet, maybe. So registering the class is essentially you uploading your entire contract code onto the chain, right? And then you can essentially create those class instances or the contracts with the real storage and things. So registering the class is putting your artifacts and things like that on chain. Okay, so the contract class registered successfully, and we are able to see the result. And I believe this is the transaction hash or address. Yes, this is the address. But now we try to again deploy the contract. Let me just see if this address exists on chain or not. Okay, so we are able to see this transaction, and this transaction was just 17 seconds back. So this is for registering our class. Okay, so you can see the contract also deployed successfully. So I guess registering the contract is first mandatory for deploying the contract. So yeah, and yeah, transaction hash we can also see this is the transaction hash for deploying our contract. Yeah, so this is the transaction hash, and I believe we would be also able to see our new contract on the Aztec Explorer. This new contract is still not there, but it will be indexed any minute. So usually, like sometimes there is a bit of a delay, like 30 seconds or a minute, but you would be able to see this. Okay, let's try to make at least one transaction so we can be sure that things on testnet is also working fine in terms of the calling the method. Okay, unexpected response, that is new. Let's try this again. Maybe that's some fee balance issue on testnet. Yeah, or maybe the transaction or contract address is still not like fully ready. I mean, on testnet things definitely takes a bit of a time. Yeah. So yeah, guys, I mean that's essentially it. Just to summarize, what I would suggest anybody starting, the journey with Aztec is try to keep things as simple as possible in the beginning because things might get really overwhelming. Trying to tackle or learn all the things at one, Noir, front end Noir integration, and handling the errors and all such thing. So keep this really simple, and yeah, feel free to reach out to me on Discord. Like my Discord username is Simbansal. Yeah, same for Telegram and Twitter. All of my usernames are same. So just reach out to me, and if you have any questions or any issues, would be definitely help you. Yeah, thank you.